Very good morning to all of you. And on behalf of NICT Academy, MNIT Jaipur, and NIT Patna, along with the other academies, I love to welcome Dr. Satyashi Nandaji and Dr. Vineet Saula, uh, other academy members, and all the participants for this. Today, we have one expert, Dr. Satyashi Nandaji, and I'm very glad to introduce him in front of you. Dr. Satyashi Jagannath Nanda is a senior member of IEEE. He received the PhD degree from School of Electrical Science, IIT Bhubaneswar, in the year 2013. Prior to that, he has completed MTech from NIT Rourkela from the Department of Electronics and Communication. He received Bachelor's of Engineering degree from Electronics and Telecommunication from ITER Bhubaneswar College, which is affiliated from the BPUT, Odisha. He was the recipient of Canadian Research Fellowship, GSEP, from the Department of Foreign Affairs and International Trade, Government of Canada, for the year 2009 to 2010, with which he has worked at University of Western Ontario, Canada. He was awarded Best PhD Thesis Award at SOC Pros 2015 by IIT Roorkee. He received the Best Research Paper Awards in 2018, 2017, 2016, and 2017 at different international conferences. He is the recipient of prestigious IEI Young Engineer Award in the field of Electronics and Telecommunication Engineering for the year 2018 and 19. He has received travel and research grant from SERB, UGC, CCSTDS, INSA, INAE. His research interests are digital signal processing, adaptive signal processing, data clustering, neural network, evolutionary computing, bio and natural inspired systems, modeling with artificial immune system. Today, Dr. Nanda is going to deliver the talk on typesetting figures and vector graphs through MATLAB. So I'm very thankful, Dr. Nanda, for your time and be here with us. Thank you so much. And now I request you to start. Thank you so much.
Thank you, Bharat sir, for a nice introduction.
Yeah, welcome.
Thank you. Thank you, sir. I am sharing my screen.
Yeah, please.
I believe my screen is visible now.
Yes, perfect.
So here I will have two sessions. So in one session, I will be discussing about the creating various figures and the details in MATLAB. And in another session, I am going to discuss about typesetting the figures and graphics in the Latex. So both the things I will be covering in the next 2 hours. So this one is a Latex template which I have downloaded from IEEE, and here I am using the Latex Text Studio file, and this is a IEEE conference regular template I have downloaded from the IEEE. The fonts are visible, sir, or shall I make it a little bit large?
They are visible in full screen.
A bit larger would be better.
Yes.
Now is it visible?
Yes. No, but the PDF is larger, but the LaTeX window has shrink.
Yes. So I want.
Can we put in the full screen for participants?
Text Studio.
That option was there, no? Full screen for participants. I think Shailesh knows it. Shailesh knows it. I think it is visible perfectly. Okay. Go ahead. No problem.
Okay.
if you can just give the link to download this template, that will be a little better.
Yes. I will share the thing about the
Please.
IEEE. They will.
Please go ahead. Please go ahead.
Sir, now is it full screen?
Yes, it is full screen now.
Okay. So over here, so this is an upcoming conference coming in our MNIT for December. People can refer this conference also. So in this conference, there are the link is there, and people can refer this IEEE CS double column conference format for submission of their papers, and this conference is up to this 31st. The last date is there. Very popular conference, IEEE ISES, which we are going to organize in this December. So this is the IEEE conference proceeding templates, which is there. You can able to look at that. There are Microsoft Word option is there, and Latex template instruction is there. So you can able to download this Latex template instruction, and after downloading it, you can able to open it in your Latex Text Studio, and then after opening it, it has a format like this, and you can change your title name, and you can observe that for 6 speaker this option is available, and you can able to put your title name of the paper over here, like it has been given neural network for classification, and corresponding author's name, and as well as organization you can able to enter, and you can write your thing about the abstract of the details, then the introduction about the papers, and you can go ahead doing it, and I will be focusing on how you are going to write the equation in this particular template, mathematical equations over here. On that one I will be focusing. So you can able to observe that here in the equation there is a very simple equation is there over here. A plus B is equal to gamma. So in this particular equation, uh, here there is a no number. You have to start with begin equation. A plus B is equal to gamma, and equation. Here there is a no number slash no number is given. So that's why on this particular equation which is there on the right side, there is no equation numbering is there. So if you will remove this no number, then you will have the corresponding equation will be available. That is A plus B is equal to gamma, and this one has come into account. When you are putting and no number, then this numbering will not be there. Okay, so in order to effectively write the equations, you need various symbols for writing the good equations. So you can able to observe that on this template I have created some amount of symbols which every author should know. The simple symbols like plus, minus, and if you want to write a plus minus, then you have to use slash pm. Then slash times you have to use for multiplication. Slash div is for division. Then slash infinity like this, that will lead to the thing infinite thing. Then slash o plus is for this convolution type of thing. You can able to observe if it is shown in highlighted thing. Then O times is for multiplication within the circle. Then there are equal to slash any is for not equal to. So here is the symbol equal to and not equal to is there. Then less than equal to is slash LE, greater than equal to is slash GE. So these two things are very important symbols because in many equations we do write less than equal to and greater than equal to in LaTeX. Then there is approximation. Slash approx is for the approximation. So this is the symbol for the approximation. Then suppose we are writing 1, 2, 3 and there are many dots we have to put. So instead of manually inserting the dots, you can use this word slash dots, which will make the uniformity, and there will be 3 dots will be for one slash dots, there will be 3 dots will be inserted inside it, and you can able to insert many number of slash dots also. Then for writing fraction, you have to use slash frac, then the numerator followed by the denominator. So slash frac, then 5 by 7. So I have written shown over here 5 by 7. And then the next thing is how to write a square root of thing. So square root here I have highlighted that z is equal to square root of x plus 1 whole square plus x square. So this is written and its corresponding output is highlighted over here. Z is equal to square root of x plus 1 square plus x square. And if we want an nth root, then square root of n x, z is equal to square root of n x, and it has been highlighted over here that z is equal to square root of n x. Then exponential, you can able to write p is equal to e to the power x plus 1, that is reported over here. Exponential p is equal to e to the power x plus 1. Then the famous LMS algorithm in adaptive signal processing or any machine learning equation, that is xt plus 1 is equal to xt plus 2 mu input into error. That is the update equation of so this is how we write the update equation xt plus 1 x underscore t plus 1, that is time instant t plus 1 is dependent upon xt plus it is 2 mu input into error signal. So any update is dependent upon the error. So modulus of x, that is represented over here like mod of x and represented in the thing. Then logarithmic of x, you can able to use ln z is equal to ln x. So you can observe that z is equal to ln x is represented over here. And then for any specific log, so p is equal to log underscore 2 7. So log underscore 2 log underscore n also you can able to put. So that will be defining the base of the logarithmic we are using. So like p is equal to log base 2 and 7. So this is how we can able to write. Then exponential in a manner e to the power minus x square is equal to suppose exponential x. So this is represented like this. So after these basic equation and basic symbols, I will tell you about some more mathematical operations, how we can able to write. The two important things you need to understand in LaTeX when you are writing the equation inside the text and writing the equation inside like separate equations. So there is a difference between them. So you can observe that here inside a particular statement, I have written some of the equations. Like you can observe that let's assume x belong x in -2 and 3 such that fx is equal to e to the power x and another function gx is equal to sine square x. So inside this particular statement, there are equations present. So these equations you have to write within the dollar symbol, like a dollar symbol at the beginning of the equation and dollar symbol at the end of the equation, and rest text you can able to write as it is. So whenever you are writing any particular equation inside a text, always use this dollar symbol for representation. Otherwise, you in the regular form, you can write it as slash begin equation and then write your own equation, then slash end equation. That is the format. So when we are instead of writing, so I think you have got about this particular example. Let's about the equation inside the text of the paragraph. So its corresponding output is represented over here. Let's assume x belongs to. So I expect that when I am zooming it out, it is being observed there. So here I am zooming it out. Let's it is visible, I think, for you whenever I am using this zoom.
Visible.
So let's assume x belongs to 2 and 3 such that fx is equal to e to the power x and another function gx is equal to sine square x. So this is how we can able to write in a perfect manner. Then suppose we are going to write multiple number of equations, then here I have written 3 equations, that is considering the derivative of the thing. So fx is equal to a simple function x cube I am considering, and taking the first derivative, f dash x is equal to 3x square, then f double dash x is equal to 6x. So taking showing you the impact of taking derivative. So you can able to observe that first one is fx is equal to x cube, that is represented over here with equation 2, that fx is equal to x cube. Then I have written f dash x is equal to 3x square and f double derivative x is equal to 6x. So over here these 3 equations have been shown you. Yeah, fx is equal to x cube, f dash x is equal to 3x square, f double dash x is equal to 6x. So these are represented by equation number 2, 3 and 4. 2, 3 and 4, these equations, 3 equations. But you can observe that by writing 3 equations like over here, one after the other, then there will be a lot of gaps between the equations. Sometimes we do not want these equations to be separated by so much of gaps. These gaps you can also able to observe over here in this PDF. We want the equations to be written simultaneously, one after the other. So for that one, you have to use equation array for writing the thing. So over here, you can observe that I have used begin equation array slash and equation array. So this equation array helps us in writing consecutive equations. So over here you observe that I have used 4 equations. Fx is equal to x cube, f dash x is equal to 3x square, f double dash x is equal to 6x, and f triple dash x is equal to 6. So 4 equations, there is very less gap between them, and these all 4 equations are represented by only one single number, not by 4 different numbers, but with only single equation numbering. So for that one, what I did that inside the equation array, I have used fx. There is a and is equal to and. This I have used because I want all the things, all the 4 equations equal to sign to be uniform, to be at the central position. So all the four equations you can observe that the equal to sign is placed at the middle part of the equations. So it is not neither left alignment nor right alignment, but it is centrally aligned. So that's why here I have put this and is equal to end. So this is how you can able to effectively write the derivative of the equations. Then let's discuss about how to write the vector and matrices in the latex. So the vectors can be represented by this particular equation that slash v is c p is suppose I want to write a vector like p and p above arrow, so I can able to use slash vec p is the vector representation of p that can be represented over here by P1, P2 and dots up to Pn. So I have used P underscore 1, P underscore 2 and P underscore n. So this I have represented for writing the vector. But the vector also can be written by putting right arrow on the P. So by another way also I have written this particular vector in the equation 7. The difference between these equation 6 and equation 7, you can able to observe that the upper one, the arrow is small size, while the lower one, the arrow is bit bigger size on the P. So you can use any of the thing. If you are writing in the upper, then you can use this slash vector format of P, or otherwise on the P you can use right arrow. Right arrow you can place above the P. So for doing that one, you have to use stackrel function, slash stackrel, then slash right arrow, then P. So with this, you can able to make a bigger arrow over the P compared to this narrow type arrow on the P for the vector. So both way it can be written. So this is how we write the thing about a single vector. Then for writing matrix in the latex, let's discuss about how we can write a matrix. So for writing a matrix, you have to create an array inside the equation. So this is how you can able to observe. I have written a matrix over here in this particular equation. So this is a pi cross n is equal to p1, p2 and up to pi. This is a bigger matrix and is equal to these type of things. One inside the matrix there are a number of uh, rows and columns, and there are a number of 1, 2, 3 and the values are moving up to z minus 1 up to z. So such type of equation we need to write that equation 8. Little bit complicated appears to be, but it will become very easy. So what we need to do is for writing such type of equation, always you just have a look. The very significant part is left side this brass uh, and right side brass, both are very big over here, that you cannot achieve with just the left square bracket or right square bracket. So for this particular achieving such type of structure, you have to use slash left and then followed by the bracket, and for ending it you need slash right and then followed by the bracket. So these two things are very important. Then inside that you have to create a array with how many columns, that you need to decide. So this particular one, it needs one particular column, whereas on this particular one you need 1, 2, 3, 4, 5. 5 columns you require. So how many columns you require to write as a matrix, that you need to consider. So over here I have one column, so I have written slash begin array C. C is for one column and located at the central location. If I have to use left, then I will use L over here, and if I have to use right, then I will use R over here. But it is centrally placed, so I have used one column and at the central location. So this is C. So again, inside that I am writing a number of vectors. You can observe P1, P2 and Pi and up to Pl. So that's why I have written this first vector as stockrel right arrow P underscore 1, then followed by a double slash is used for the next line, then stockrel right arrow P2, then double slash for next line. Then this is 4 columns I have used to create this particular column, and then up to Pi I have moved on for doing this. And to its right part, you can observe I have a lot of columns, that is 5 columns are there. So like I have written over here slash begin array C for one column, so I will write over here for 5 columns 5C. So that is represented central allocated centralized position. Each one will be placed at the center, and for one column to other column I will use AND. So this is one will be for the first line, and then first column, then for the next column this AND is there, and then followed by one, and then the AND, and then double dot, then end for the next line. So like this you will go on writing line by line until and unless you reach the end of the matrix. So and at the end you have to end the particular array which you have created at the beginning, and then slash right, and the right side bracket will close. So this is how you have created the matrix over here using the latex. Then the next thing is how to write the discrete form of equations, that is the summation and the sum and product in the discrete mathematics, mostly which is used in signal processing and all other VLSI implementation techniques. So here I have written the equation like this, that xk is equal to summation n is equal to 0 to 1 xn e to the power minus j to pi kn by n. So this is nothing but the discrete Fourier transform of xn. So DFT of xn. So this is the very simple mathematical formulation. So this is how we are going to write in latex. So for this particular one, I have written xk is equal to sum, this summation n is equal to 0 to n minus 1. The lower part, you can consider the lower part n is equal to 0, that will be written first, and the upper part n is n minus 1, that will be written later. So you can observe I have included slash sum, then underscore is for lower part, and the cap is for upper part. So underscore n is equal to 0, lower part it has been written, then cap n minus 1, that is for the upper part, writing the upper part, then xn. Then you can observe I have written e to the power minus and then within that there is a fraction, j 2 pi k n is on the numerator part and capital N is on the denominator part. So writing for this one, I have written e to the power e cap, then we inside that minus, then I have used fraction. The numerator part is j 2 pi kn. So over here it is j 2 pi kn, and then denominator part is capital N. So after the bracket it is written capital N. So this is how you can write the famous discrete Fourier transform expression. Then double summation, many of the times in discrete mathematics we require double summation. So for writing that particular one, as you can able to observe over here, P is equal to summation I is equal to 1 to K, and then summation J is equal to 1 to L, Qi, Qj. So both the things we want that the double summation. So for the first time summation, so I have written over here summation upper part is P is equal to summation upper part is K and lower part is I is equal to 1, and summation then further followed by the summation. uh, uh, you can observe that two summation, here it is summation 1, and upper part is capital K and lower part is I is equal to 1, and here again a summation that is J is equal to 1 at lower part and upper part is capital L, then Qi and Qj. So both the things, this is the expression for the P. Then discrete product. So writing the discrete product, so somebody has put a question that can we write the equations without numbers? Yes, you can able to write the equations without number by including a thing slash no number. If you use this one slash no and you MBER. If you inside any equation, if you use this particular statement slash no number, then this numbering 8, 9, 10, these numbers will not come. So you can use them without by using this particular one slash no number. So for making a thing like the summation, so for product term you can able to observe n is equal to j product j is equal to 1 to k a j, like this product you can able to use n is equal to slash product j is equal to 1 to k j underscore, it is written j is equal to 1, so j is equal to 1 lie below, and upper part on the product it is capital, this is small k and a underscore j. So this is how we have written that n is equal to small j is equal to 1 to k product aj. So like that you can able to write double product also, like double sum over here. Similarly over here double product, that is I is equal to 1 to k and j is equal to 1 to l, qi qj. So over here, this is about the double product. P is equal to product. I is equal to 1 to k. I is equal to 1 is at the lower part, so that's why underscore, and k is on the upper part, that's why on the top. Similarly, product j is equal to 1 to capital L, so j is equal to 1 is at underscore, and cap is L is for the upper part, so qi and qj. So this is how we can able to write the sum and product. Then there is another important part is how to write limit. So writing limit, you can able to observe this is a very famous limit equation. Limit x approaches 0, sin x by x is equal to 1, one of the very popular writing limit. And another thing, writing y is equal to limit x approaches minus infinite fx. So how to write this particular type of equations in latex? So here for writing limit x approaches 0. So I have written slash lim for the limit, and then below the limit x approaches 0. If you can observe below the limit x approaches 0. So limit underscore x to 0. X to 0, that will create this particular arrow. X approaches 0, so x tends to 0, so x to 0 underscore, inside that you have to write like this, limit underscore x to 0, then fraction sin x by x is equal to 1. So FRSC equation you will use. Then similar way y is equal to limit x up to x to minus infinity and fx. So that is how we can able to write the limit. Then I have already told you how to write about the derivative, direct derivative that I have told you, that is fx is equal to x cube, f dash x is equal to 3x square, f double dash x is equal to 6x. We have discussed about the direct derivative. Then we have to discuss about the partial derivative, how to write the partial derivative. So for writing partial derivative, like z is equal to del f by del x, or z is equal to del square f by del x square. So this is how we can able to write this del type of thing, partial derivative expression. So for that one we are using z is equal to, you can observe fraction, then slash partial. Slash partial is for partial derivative. Slash partial f divided by this partial of x. So you can observe this partial term, that is making this del symbol effective. So the next one is making this square. So this square you can able to use by del partial, this is slash partial, then upper cap 2. So that will make you del square. So del square f by del x square. So this is how you can able to write the partial derivative. Then the next important part is writing the integration in latex. So in integration, we have to write like this, that suppose y is equal to integral of fx dx. Okay, so for that one we will write y is equal to integral fx slash int is for the integral fx dx. Then integral with limit like this, that y is equal to integral from lower limit is a, upper limit is b, fx dx. So for that one, with this y is equal to integral underscore a, underscore is for the lower one and cap is for the upper one. So cap b fx dx in the same way. Okay, so for double integral, like z is equal to integral a to b c to d fx y dx dy. So this type of equations we can able to do in this particular manner, that is z is equal to integral underscore a of b, then again slash integral underscore c of d fxy dx dy. So that will make out double integral for the particular thing. Now integral with a limited bound. So sometimes we bound the integral, so that is the within the limited value. So over here that example is given on the left side, the integral bound between a to b, that is x square dx is equal to this x square dx, its integral will become 1 by 3 x cube. So 1 by 3 x cube, then we have to again put the limit a and b, that is upper limit is b, lower limit is a. So substitute, you have to substitute in the next step, you have to substitute the value of b and a in this particular equation. So on the left side also there is a bound, and on the right side also the bound. So this type of case you face when you use them inside the derivation. So for writing this type of thing, you can able to observe that integral left side is same, and like a to b and x square dx. Okay, then the right side, the most crucial part is how to set this bigger line and limit lower is a and upper is big. So for this particular bigger line, you can use slash big and this particular symbol, and underscore A and upper part is B. So that will make out the thing 1 by 3 x cube. Okay. So then using double integral, you can many times we use double integral and triple integral also. So you can observe one example, z is equal to double integral fxy dx dy. So over here, this is the expression that for one integration you will use slash int. For double integration, double int. So over here you observe for double integral I have used slash iint. So that is for the double integral fxy dx dy. Okay. So similarly for the triple integral, that is next w is equal to triple integral fxyz dx dy dz. So for that one I have used slash triple I and t. So that is for triple integral. And many times we need surface integral, that is O and then integral. So that has been written surface integral like w is equal to surface integral like this, O integral fx yz dx dy dz. So this is w is equal to O int fx yz dx dy dz. Then these are all type of mathematical case expressions I have discussed with you. Then there are also some typical cases, like sometimes we want to write that there are multiple case studies. If this condition is true, then something will be there, otherwise something will be there. So mathematically we can able to express just a special case study. XRS is equal to 1 by J. You observe there is a bracket and we have two conditions over here. If some part is some equation, if this condition on the right side is true, then it will lead to 1 by J. Otherwise, it will lead to 0. So like that, this type of equation, how to write it. So for this particular one, you have to use the thing like slash left and then slash this particular left bracket, and that will be terminated by slash right dot. So inside this again I have to use various thing that I have divided this entire thing into two columns. 1 by j and 0 will be one column, and if and otherwise part will be another column. So for that particular one, I have created inside this a array. So begin array, and I have made it two columns. So left alignment for both the columns you can able to observe. Then on the left first part I have written fraction 1 by j, that is 1 by j and the 0 on the thing. And for the right side, then I have again written if this particular condition is true, then it will lead to 1 by j, otherwise it will lead to 0. So for the right side, if this condition, the condition has been written, and otherwise it will lead to 0. So this is very important, and there are many such type of case study you can able to formulate as per your need whenever you write in the paper. Then there are some important aspect that how to write the equations inside the tables. So we are writing the equations inside the text like this. We are writing the equations normally like with the equation numbers like this on the right side. But how to write equations inside the table? So that is the another important aspect we are going to discuss. So this is in the latex, we have created a very small table. You can observe that begin table, and the table is placed on the top, and we are going to write about the letters and numbers over here. So in the begin tabular, I have kept four columns. One column is for this letter numbers letters, and on the right side there are three columns like A, B, C, then 1, 2, 3, D, E, F, 3 rows and 3 columns. So for this, I have put left alignment, and then this triple C is for 3 columns. Then for the left part, I have written letters, then followed by this A, B, C. So for each column, this separation is by the end. Okay. And you can observe that here at the B, here there are the columns which are demarcated, letters, numbers, letters. After that, one vertical line is there, and C3F. After then, right, there is vertical line is there. So for these vertical lines, I have used over here in this. So before the L, there is vertical line. After the L, there is vertical line. After the last C, there is vertical line. So for that one, this type of things has been created. So if I will use the entire things within the vertical lines, then this table will be completely filled with the verticals. Like you can observe that this is now completely filled with all verticals. So this is a complete one. And if I will remove those things over here, so then those verticals will be removed. So in IEEE format, you can able to use the verticals, but in Elsevier formats, they do not allow, they want the equations to be written in this particular format, not like the vertical lines. Okay, so they do not want you to put vertical lines over there. And my objective over here is to show you that how to write the equations inside the table. So we have, you can observe that in the table 2, we are comparing between the transforms. So there are two transforms. One is, very popular discrete Fourier transform, and another one is fast Fourier transform. That is the FFT, DFT and FFT in the signal processing. So both the have almost similar type of expression, but the computational complexity of fast Fourier transform is lower. So this is the equation. You can observe I have written inside this particular table. So this is the expression of DFT which is written inside the table. That is the equation, and the computational complexity O(n) square for discrete Fourier transform, and for fast Fourier transform O(n) log n. So that has been described over here. So over here, the complexity, you can able to observe inside the table. I have written over here 3 columns I have taken L, C, C. So first one is left alignment, then the rest 2 are in central alignment. So the comparison between this discrete Fourier transform and fast Fourier transform. So within the table, when I am writing, I have to write within the dollars. So within the dollars, I have written the equations over here. You can able to observe O(n) square also I have written inside the dollar. O(n) log n also I have written inside the dollar. And between each column, I am putting this ampersand. So that demarcates the column from one to other. So this is how you can able to write the tables, begin table and end table, and inside the begin tabular and end tabular, you can write the equations inside the table. Then I will discuss more about the figures and creation of figures bit in Latex, and then the creating the figures in MATLAB also I will be discussing. But I want to take up some questions if you have in the last 1 hour.
Thank you, Nandaji. Like, it's the better way that surely if they ask some questions, so they will be refreshed, and as well as they will get
Yes,
query cleared from your side.
yes.
Uh, so there is a one question I think you have already handled it
Yeah,
by
in
Shyam
between.
Deshmukh. How can we write equations without numbering?
Yeah, slash no number, that is
Yes.
they have to use /no number.
Participants, if you have any queries in this presentations, you can please write it to us here so that our experts can manage it. So there is a one question from Mani Kandan M. How to place a table exactly below the table?
Okay, so
Sorry,
you
below the
have,
figure. Actually, he asked two things, like
Hmm.
how to place a table exactly below the table, and another question is like that how to place a table exactly below the figure. So I hope
Okay.
second one is
So for both the things, you have to use only one thing, that is begin table, then inside there is a bracket, and here there is a H. So if you will place this H, then the particular table will be placed at that instant immediately. So if you will put T over here, capital T, then that will be top on the top, or small t, that will be on the top of the page, and it will be a B will be for the bottom of the page, and at the immediate instant, then he has to put H.
yes.
So I think it will be clear. If on
Yes,
the
even
top
I
of
think
the
like it is clear to the yes, he said thank you, sir. Participants, if you have any other queries, please raise it. So the question is from Ranjan Bhalia. After downloading Latex template of particular journal, it is not execute in the Latex software. Question is not
then
essentially
then he has to update the Latex software, update the Mictex. Once the Mictex, if it is not running, then you have to update the Mictex package. So once the Mictex package is updated, then that will automatically run.
I hope Ranjan Maleji, your query is solved.
Your Mictex you have to upgrade.
So there is a one question from Muhammad Aizaz. How to draw image in table?
Image in table, that I will discuss now. After this break, I will discuss how to draw image in the table.
Yes. So Muhammad Aizaz, your query will be solved in the next lecture. So just please wait it, and after that, if you find any more query, you can just raise it over here. Thank you.
So we will take a little break, sir, for 2-3 minutes. Then again we will start the next session. Maybe 5 minutes break.
Yes, sir. We can take 5 minutes break, and then we can join it over here. So participants, please stay here. If you have no queries, you can take a break of 2-3 minutes, have water and tea with you, and again join the informative session from Dr. Nanda.
Yes, sir. We can start.
Yes.
After 2-3 minutes.
Sir, there is a one thing like Ranjan Valia is asking, like please share the text file of this session. Yes, surely we will request Dr. Nanda to share this file to you, to all of us.
I have shared with Professor Binit sir. So sir will share it with participants.
Surely. Thank you.
Okay.
सर आपके टेबल
₹10 की एक है।
तो Sailesh, are you selling something online? 10 rupees की है।
Shailesh ji, please mute your
म्यूट
mic.
कर लो भाई।
Nanda sir? Yes, sir. Welcome back, Dr. Nanda.
Sir, we will resume the session. Can I start?
Yes. Yes, I think we can start. Participants, we are going to start the next session from Professor Nanda. So, Professor Nanda, like we can resume the session for 1 second. Thank you so much.
So I am going to answer the query about the typesetting of figures. And there was a query also about how to typeset the figures inside the table also. So for setting the figure in the latex, so we have to include a figure like this, begin figure, and over here also column H is for at this instant only. If you want the figure to be placed on the top, then you have to include T, and if you have to place the thing at bottom, then you have to use B. So over here H. So you can use width and height. So width is equal to 4 centimeter and height is equal to 4 centimeter and image 1. So obviously I have used my image only. So width and height, with this you can able to control the size of the image. And there is a caption and label also you can use. So this caption will come inside like over here, figure 1, my image. So my image is the caption. So this is how you insert a figure inside your latex template. Then for creating multiple number of figures, like sometimes we want to insert 3 different figures, like one figure at A, another figure at B, and another figure at C. So, and we want that the figure caption should have figure 2, my pictures, my picture 1, my picture 2, and my picture 3. So like this type of environment we want to create, the 2, 3 pictures or 4 pictures on one particular side. So for that particular one, you have to use sub figures inside the figure. So you can able to observe that over here, I have used the begin figure and end figure, and inside that there are 3 sub figures I have used. So the sub figure my image 1, that is for A, sub figure my image 2 for this image B, and sub figure my image 3 is for the third sub figure. So this is the impact of sub figure. And the image width and height you can also control by setting the width and height like this, or you can use, instead of width and height, you can use scale. Scale is equal to 0.6. That will automatically adjust the image size to 0.6%, 60%. 60%, and like that scale is equal to 0.9 will make 90% of the image size. So multiple number of image in the form of A, B, and C you can able to insert inside one particular figure. Okay, with this option sub figure / sub figure inside the figure. Then the next thing is you can observe this is a double column template. That means the thing is totally 2 column. The manuscript is of 2 column. If I want the figures to be placed on the entire thing with the entire page without this division of column, that means I want 5 figures and all the figures are to be placed like this, means across the entire page covering both the columns, and below the figure I will have my other my caption for the entire page, so that I can use it by putting figure star. If instead of begin figure and end figure, if I will use slash begin figure star and end figure star, then that will make the figure into whole page, so covering both the columns. So that you need to use. And here I have used, so again, soft figure for inserting 5 of the images. 6 images. So image 1, 2, 3, 4, 5, 6. So 6 images I have used. And similarly, the caption is also written for 6 images. So over here, you can able to observe scale. I have kept it just 0.2 and inserted these images. If I will change the scale, then this image size will be changing. So this is how you can able to insert images inside the latex. Then images inside the table. So over here inside a table we have inserted a image, my image, and on the second column there are some advantage and on the third column there are some disadvantage. So inside the table you can insert image by using mini page. So over here you can observe I have created a table. Inside the table I have created a tabular, and I have made it the columns of 2 cm and the central part of central type alignment. And inside the image I have inside this I have created a begin mini page and mini page, and inside this mini page I have ensured what should be the text width, that is the 0.2 I have set, and I have scaled the image to 0.4 and inserted it on the first column, whereas on the second column and third column I have kept the texts and text with bullets also. So text with these bullets you can use it by creating begin itemize, and inside the item you can able to write the things and mm, use them accordingly. And this and is making from one column to the next column separable. So the inside this, so this and is making the columns separate, and this is how we can able to create various type of images and insert the images inside the table, also create multiple image and use of soft figures also to create multiple image and keep them inside the particular template. Okay, I hope this type of formulation would help you to understand about the images. And then I will tell you about some little bit things about the MATLAB and how to plot various things in MATLAB and create various figures for the simulation purpose. So this is the MATLAB. I am opening it. Our institute has a MATLAB license for 2015 version. So I am using that one. You can use the latest version also for MATLAB 2020-21, but I will be demonstrating you in this 2015 version. it will take a little bit time to open the software, as MATLAB is a heavy software. In the meanwhile, if you have any doubt on the figure and table in the LaTeX, you can ask me also. So I believe that the font size in my MATLAB screen is visible. Okay, so whenever you are writing anything on the MATLAB on this editor, so I will show you, demonstrate that when you start writing, you will include these three lines: CLC, close all, and clear all, so that your previous users, all the programs and the files, necessary things will be getting clear, and it will give you a platform ready to operate. So fine, our things are running. So what I will do, I will tell you that how to plot simple graphs, curves, and create your own things in MATLAB. So this is a simple vector. X is equal to 0 to with increment of 1 up to 9. So and we have to plot this particular thing. So I have run this particular one. So you can observe that a figure has come out over here, and this is increasing from 1 to 10, and over here you observe that this X is like 0, 1, 2, 3 up to 9, and that plot has been there in the y-axis, that 0 to up to 9. This is a straight linear curve you can able to observe by using the command plot x. You can plot this, and if you want discrete, that every point to be shown, then you can use this command stem x. That will help you to discretize plot of the same thing. So here two figures you can observe. Between these two plots, that is the plot x and stem x, I have used a figure word. So using this word figure, you can create another figure. So here there are two figures. One is continuous version and another one is discrete version. You can able to observe them parallelly. That is the value 0. At the first point the value is 0, second point value is 1, third point value is 2. So this is the same, both the things are same graph, but this is left side is obtained using word plot and right side is obtained using word stem. So left side is for continuous plot, right side is for discrete plot. So this is the difference between the command plot and stem in MATLAB. So you can plot any linear curve like this, any linear vector like this. So this is 1 unit gap. So you can able to change the gap from 1 to like 0.5. So then the number of things will change, more number of plots. So you observe that with changing 0.5, you can observe there are many points have come into account. Okay. So now we will have a look how to plot a very popular simple thing, that is sin x. So for sin x, everybody knows that this sin x command, it is a periodic signal between 0 to 2 pi. So I have created a x that is 0 with 0.1 sampling 0 to 2 pi. I have created a vector that is considering 0 to 0.1 spacing up to 2 pi, and here I am taking y is equal to sin x. So this x versus y I am plotting. Then I will be labeling the graph, that is the x label will be labeled as x, y label will be sin of x, and the title of the figure will be sine curve. So let's run it. So you can able to observe that this is the plot, sinusoidal plot. Okay, of frequency 0 to 2 pi. 2 pi, you know, it is pi is 3.12, so it's 3.14, so 6.28, so up to 6.28, this is there one particular sinusoidal curve. So if I want to make the frequency, okay, sine wave with multiple frequency, that is uh, the frequency is suppose sine f of x, and you can able to use as f is equal to suppose 2. Then you will observe that you will have two sinusoids within 0 to 2 pi. So like that, the frequency you can able to set it as 5 also. So there are 5 things. So like that, you can do the continuous plot of the sinusoidal function. If you want a discrete plot also, you can able to do by replacing the plot with stem. So this is our sinusoidal function, sine wave. Okay. So I hope it is clear about how to plot a simple function sin x with this. Then we are going to do more number of plots in a simple window. So what we are going to do, we are going to plot a sine function as well as a cosine function together. So considering 0 to 2 pi with 0.1 gap, and I want to plot sin x as well as cos x together. So the sin x I am plotting with red color. So the color for red I have inserted over here, xy, and with red color. Then I am going to plot the cosine signal with green color over here, xz with green color. So let's run the thing. So you can observe that the sinusoidal signal in this is with the red color between 0 to 2 pi, and the cosine signal is with green color over here shown. So both the things are overlapping over here. So to create such type of overlapping plot, you need to use this command, hold on. So one plot, then this command hold on, then plot another thing, so that both the things will be overlapped one above the other. So over here there are two graphs. one above the other. Then you have to use insert legend. So with this, you can able to create two data. You can observe data one is this. So suppose I am making it data one is your sine function, sine of x, and data 2 is cosine function, that is cos of x. So like that, you can able to use sine and cosine to create simultaneously overlapping curves. So many other curves, if you want to plot in one particular window over here, you can able to do it. And of course, here there are in the insert, there are X label is also there. And in the X label, you can also name it as samples. And in the Y label, amplitude, you can able to write. So like that, you can create any particular graph, and you can use legend, you can use X label, Y label to insert them. So like that, two graphs over here, you have overlapped inside one window. Then we will understand another thing to create subplots. So here there are multiple plots I want to create within one window. Suppose I am creating four functions: sine, cosine, tan, and cot. All four things I want to plot between 0 to 2 pi. So x I have taken 0 to 0.1 with 2 pi. Then I am creating sinusoidal function, cosine function, tangent function, and cot function. So for this, what I am doing is this particular window, figure window. This figure window, I want to divide it in 2 by 2. That instead of one figure over here, I will obtain four figures simultaneously, four partitions. So I am making it subplot 2 by 2, 2 by 2, 1, and inside that I am putting this first one, sinusoidal signal with red color. So if you can observe, let me run this particular code. So you observe that what happened is that particular bigger size figure that has been partitioned into four subplots. So the subplot 2 by 2, 2 by 2 has made it this 2 cross 2 matrix, that is over here 2 by 2, and in the 2 by 2, the first one is sinusoidal, second one is cosine, third one is tan, and fourth one is cot. So sine, cos, tan, and cot, four things have been plotted with red, green, blue, and black color, four sinusoidal function. So for this subplot 2, 2, 1. So 2 by 2 matrix, this is 2 by 2, and its first position is for sin x. Then the second position 2, 2, 2. So the second position is for cosine. So second position is demonstrated over here by cosine. Then 2, 2, 3 is for tan. That is the blue one over here. So over here you can observe 2, 2, 3 is for the blue one, and 224 is for the K, that is the black one. So over here you can observe that four different figures have been incorporated over here, inserted over here with the subplot command. Now let's we have understood about the sinusoidal signal and how to plot them, how to do multiple plots together, how to multiple plots on one particular figure, and how to make subplots and make many figures on one particular figure. Then the next thing we are going to discuss about how to plot a circle. Circle, you know, it does have a radius, and in x and y unit, you need to plot it. So what I am going to do is I have taken the radius of the circle as 2. Then I want x and y to be 0, 0. The circle should be placed at 0, 0 origin. Then I have taken how to plot the thing, that is x plus r cos theta plus as the x unit, and for the y unit it is y plus r sin theta. So the r is the radius, so r cos theta. So theta I have taken 0 to between 0 to 2 pi, and I have made it pi by 24 as the sampling rate. So with 0 to pi by 24 gap, I am moving it up to 2 pi, and that thereby using x plus r cos theta in the x unit and x plus y plus r sin theta in the y unit. So this x unit and y unit, I am plotting them, and I am making the axis equal. So with this plot, if you will run it, so you can able to find out it is a circle with radius is equal to 2, and the circle is placed at 0, 0 as the origin at the center, and this axis, if you can able to observe that -2 to 2 it is varying, and on this y-axis also it is varying -2 to 2. So this is your circle that has been drawn with MATLAB. Then the next thing I told you about we have plot the sinusoidal function circle. Then we need to plot a wave function. Wave function is very, very important from practical point of view. Many sinusoidal, many practical applications of wave functions in signal processing. So over here you can observe that I have taken the signal between -2 pi to 2 pi, and for this I have calculated the length, and my wave function is nothing but, all of you know, it is sinc function. Sinc function, that is sine pi x divided by pi x. So I have made it, if x is equal to xi is equal to 0, then yi is equal to 1. Otherwise yi is equal to sine pi xi divided by pi xi, and that one I am going to plot it with respect to the xy. So this is the thing about the wave function. So sine pi x by pi x. So you can able to observe this particular wave function. Okay. So on the x-axis, it is I have plotted between -2 pi to 2 pi. So your function in x-axis is varying from -2 pi to -2 pi to +2 pi, and in the y-axis sine pi x by pi x. So this is the wave function. You can able to plot it like this, sine pi x by pi x. Then I will discuss with you how to plot random signal. So in MATLAB, we can able to plot random signals. So for many modeling and simulations, we need random signals. So how about the characteristics of random signals? So that also we can able to discuss. So this is a random signal, rand 1, 2000. So it will create a vector of 2000 number of random signals. So it will give us a sequence of 2000 unit random sequence. So we are going to plot this one. So you can observe that on the x-axis it is 0 to 2000 and random numbers have been created between 0 to 1. The y-axis level is between 0 to 1. So between 0 to 1, 2000 number of random numbers have been created. So what is the characteristics of these random numbers? If you are using the random number with RAND function, so its power spectral density will be uniform because it will be a uniformly distributed signal. So for this one, if we want to observe its whether it is uniform or not, so its characteristics you can plot with the histogram of X. So I have plotted this one, so you can have a look at it. So this is the characteristics. So I have taken a little bit more number of samples, so it will take a little bit time to show you. Here are the plots, figure 1 and figure 2. So this is showing the statistics of the random signal. So in and around this 200 number of samples, this is showing you the uniform distribution. So the almost this is between 0 to 1 and so every point, so as we have taken 2000 number of samples, so in every division almost there are 200 number of samples. So 10 divisions, so 200 into 10 is 2000. So like that, this 2000 number of samples which are there that are between 0 to 1. So those all samples have been uniformly distributed. So between 0 to 1, 200 samples have been generated, 0.1 to 0.2, again 200 almost, and like that almost near about 200 number of samples have been generated for all of them. So if we will increase this 2000 into 10,000, okay. So if I will use it for 10,000 and I am plotting it, running it again, you can observe. So if I am using 10,000, then this is 10,000 number of random samples, and you can observe in and around 1000. So for every particular signal, it is between 0 to 0.1, 1000 samples have been plotted, 0.1 to 0.2, again 1000 number of samples. So this is the uniform distribution of the rand function. The spectral density is uniform. So like that, if you are going to use the Gaussian based randomness, that is rand n signal, then the power spectral density will be Gaussian. The characteristics of the signal will be Gaussian. So let's plot its histogram plot. So you can observe that here this particular signal is now no more between 0 to 1, but it is between some -3, -4 to +4. It is varying 2000 number of samples, and the density of the signal with histogram plot you can observe it is a bell shape. That is the Gaussian signal. So the random RAND function, if you are using, that is uniformly distributed signal, and RANDN will be for Gaussian distributed signal. So I hope you have understood about the characteristics of the signal and their spectral density. Then the next important thing I want to tell you about how to plot, how to do 2D and 3D data plotting. So here I will show you a popular, very popular data matrix, that is a iris flower data. So I am loading the data, this data set iris m .m, that has been downloaded from UCI machine learning repository. So I will also share this particular file with you. So this particular one will plot it. Okay, so this is a flower data. Okay, so loading this and plotting it, you can observe that it has 150 number of observation, and it's sepal width versus sepal length. So these are dotted circles. So these uh, x-axis is varying between 4 to 8 and y-axis is varying between 2 to 4.5. So every data point is represented with a circle over here in this particular plot. So this is with a 2D plot, and here I am plotting the column 1 versus column 2 with circles of black color. So you can change it to red color also. So any other color also you can able to use to represent your thing. Now for the same thing, suppose we want to plot the third dimension, that is a 3D plot. So you have to use this command plot 3 and use this particular data set, iris flower data set. It's sepal length, sepal width versus petal length and petal width. So 4 columns are there. So if you wish, so you can plot its 3 dimension also, and I can make the grid on and label this particular data with the 3D features. So with plot 3 you can observe, so this is the 3D view of the particular data, and this is the 2D view. So you can able to compare that this is sepal length versus sepal width. So this is in 2 dimension. So this is sepal length versus sepal width versus petal length. So in the 3 dimension, you can able to observe the data's third column introducing the 3D plot over here. So with this kind of 3D plot you can do with MATLAB, and you can able to observe about the characteristics of the data more clearly over here. So here there is a lot of bunch of group of data over here, and there are other bunches of group of data over here. So you can able to do analysis like this also. Here there is one particular bunch of data, and at other places there are other. So like this you can able to do the discrete point plots in 2D and 3D. Then there are surface and contour plots also you can able to do with MATLAB. So this I was talking about the data points interpretation. That is, these are the data plot in the 2D and 3D. So how you can able to plot the data points in 2D and 3D. Then I will be discussing about how you will do the surface plot and contour plots in 2D and 3D. So this is about the 3D surface and contour plots. So here what I have taken is to demonstrate it. I have taken two variables in the x and y axis. So W1 is varying between -50 to 50, and W2 is another variable which is varying between -50 to 50. So both the x and y axis, they are varying between -50 to 50, and the z axis, it is a function of x and y. So if you can able to observe, the j is a function of W1 plus 51 plus W2 plus 51. So this is a function, some W1 square plus W2 square, and W1 W2 into cos 2 pi by 5, 2 into W2 sin 2 pi by 5 plus 2. Like this is a nonlinear function. And for in order to do the 3D plot, considering the W1 and W2, I have created a mesh grid. Okay, so with this mesh grid, you can able to plot this particular figure, okay, of the J. So let's run this particular thing. So this is the 3D plot of the MMSC surface, that is the mean square error surface. So you can able to do it with the mesh or with the surf. So if you are using the mesh, you can able to observe that this is the plot. So this is varying between the W1 is varying and W2 is varying on this axis, and this J as a nonlinear function that is varying in the 3D axis. So you can able to have a look at this 3D plot, and you can able to visualize it from various view also. You can rotate it in the 3 dimension, and you can observe its characteristics also from various angles. So this is the surface with one minima at 0, 0. So this is the 3-dimensional error surface plot of mean square error for a particular model. So like this, you can able to do other type of 3D plots also with this is with mesh. And if you want so this is mesh means this is not solidly filled. So if you can observe, this is not so solidly filled. So the solid filled one also you can able to do it by using the surface plot. This is mesh of J, and if you want surface of J, then it will be fully filled one. So this is the fully filled one of the surface function. So completely filled surface. So completely filled one, not like a mesh surface, but a completely filled surface. And this particular one, the 3D ones, you can able to do the contour plot also. So for contour plot, this 3D will be visualized in the form of 2D. So you can able to observe here I have done the contour of this J either with respect to W1 or with respect to W2. So this J with respect to W1 we have done the contour plot. So you can able to observe that when you have run, so this is the 3D plot and this is corresponding the contour plot with respect to W1 W2 versus contour plot. So at 50 and 50 the corresponding value is 0 and at the corner these values are slowly you can able to observe these yellow points over here and these yellow points are over here. You can able to have a look. These are higher values and the blue points they are the lower values. Minima is at 50 and 50. So this is the corresponding contour plot, and in the contour and in this type of surface also you can take the gradient and you can plot the gradient of the surface also if you wish. Take the derivative of the thing and then plot the gradient plot for such type of surfaces. And there are many more analysis also you can able to do. So for this particular surface, I will show you the gradient plot. So this is the quiver gradient plot over here. You can observe this is the thing, and with more close observation, if you will make the thing, then the gradient are pointing outwards. You see the arrows; they are pointing outwards in this particular gradient curve. So this is the gradient curve in the entire surface. So this is the MMSC. This is the surface plot, and this is its corresponding contour plot, and this is the corresponding contour plot, and this is the corresponding gradient plot. By taking the derivative of the surface, that is the gradient. The gradients are pointing outwards, so this is the gradient minus 50 to 50, and this is the thing. So gradients are pointing outwards, so you can able to observe the gradient plots. So I hope our in this particular 2 hours we have learned a lot of things about how to create the figures, equations, and the things using the MATLAB as well as in the Latex. So if you have any doubt, then I will be happy to answer your queries.
Thank you, Dr. Nanda. I don't know if you have answered this query. Sir, I was using begin align for equation. An unnecessary space has created below the equation. How to get rid of this extra space?
So V skip they can able to use. For V skip some negative value, then that will remove the particular space option.
Well, how do we convert any MATLAB equation directly to LaTeX?
MATLAB equation they have to write it in Latex. There is no direct conversion. Someone has to write it in Latex.
Can we crop the image after calling? This is asked by Dr. Rajshekhar Manda. I'm not sure what he is asking, so let me try to unmute him. Dr. Rajshekhar, you are unmuted.
Yes, sir. Yes, sir. Yes, sir.
Can you clarify what's your query?
1 minute.
Can we crop the image after calling?
Yes, sir, after calling into Latex. Yes.
After calling into Latex, you can able to crop the image, but for that particular one, there are multiple things you need to do. Whether your image is in EPS format or in JPG and PNG format, that you need to have a look. So if it is in JPG and PNG, then you have to do the things with the corresponding software. Acrobat and all other are very good for them. But if it is EPS, then you can use it, use the Latex tool to crop it to the desired value.
Okay, thank you, sir. Thank you.
What is the role of log files in LaTeX? Shall I answer?
Yes, please.
You can use the log files to rectify your LaTeX code to remove any errors or warnings which may come up. That is the usual role which it is useful for. And there's another question. In the equations shown above, what does \m box stand for?
That backslash M box stands for writing the equations in normal mode, not in italic mode. If you use backslash M box, then inside text will be in normal letter. It will not be in equation based italic letters.
There's another one. How can I keep one figure inside another figure?
One figure inside another figure. You can use overlapping of curves.
Overlap.
Yes. Hold on is the command.
Hold on.
One figure will be plotted, then after that hold on, then next one will be plotted.
In MATLAB, using MATLAB,
Using MATLAB.
Put multiple plots in a single figure.
Yes, in MATLAB.
Okay. Will include graphics figure dimensions be specific to any journal?
No, it is not specific to any journal. Include graphics will be working for all the journal type. That is a common command of Latex to include the
There's
figures.
another question. I am unable to download IEEE template on Overleaf. I think I can answer that. You need not download this IEEE template on Overleaf. What you should do is just open it in and it will directly open in Overleaf. If you download it, it will come onto your desktop. So just open it and it will open in Overleaf. How to increase the resolution of the graph?
Resolution of the graph. You can use the proper scaling for improving it. The scale is, you can set it 0.3, 0.4, 0.8, whatever thing you need. Or if the things is not working proper, then you need to in MATLAB, whenever you are saving the picture, you can save it in EPS file .eps and import it in Latex. So the EPS file will always have very good resolution. Even if you multiply it with 20 or 30 times, then also the resolution will not deteriorate if you are using EPS.
Yes. So there's a question by Amrita and she wants to know what is meant by vector quality, and Saula sir has already answered. So if you are using EPS format to save the MATLAB figures, then you will have your desired quality. the vector.
Yes, that quality will always be maintained if you are using EPS.
Yes. So there are some more questions.
Instead of using .fig as MATLAB's by default saving option is .fig, .figure files. So instead of them, they can save it as .eps file.
But there's, I think, a small catch. If you save it as EPS, you cannot edit the same again in MATLAB.
Yes, yes.
So you need to have a copy of your original .fig also.
.fig also they have to keep.
Otherwise, you'll have to generate it again. MATLAB code. There's a question. Do we need to specify any package before using equations? I think most of the equations do not need any package.
Do not need any package.
But some special.
Or sometimes some special case they need a package.
Yeah, it may be AMS math or something.
Like this use package AMS math, AMS symbol, AMS font. So you can use package algorithmic.
Yeah. There's another question. How
And
to
use package array also.
Yeah, array.
Okay, sir.
If you permit, I can add to that.
Sir, sir.
Usually for equation spacing and multi-line equations, it has been found that IEEE eqn array or IEEE eqn array package, which is separately available, should be included, because that IEEE eqn array package it takes care of all your spacing and multi-line equations with a proper formatting. We do not need to use CLS file from IEEE. IEEE eqn array is a separate package, can be used with any CLS file. So that is quite good. Thank you.
There's another question. How to become expert in MATLAB?
By doing programming daily.
How
if you will not program continuously, then you will lose touch.
Yeah. Very good answer.
There's another question. How we put image in corner of page or logo of any company?
Didn't get again.
I think as a background, if you want to put an image in the corner of a page, a logo, say. How do you put a logo at the corner of a page?
Usually, you want my help?
For presentations.
I also don't know much about it, but one way out is there. You want my help? We can use mini page. We can use mini page.
Yes.
A small mini page of appropriate size and place it at proper place in the complete page. And then inside that you can have the figure flow. Put your logo there. So that all text outside the mini page will adjust to it. This is only one way I know. There are other ways where we can have a complete page defined, including the logo. I'm not remembering how to do that, but it is there.
Google can,
In Beamer also it can be easily done.
Beamer is straightforward. You can put a logo and there is a command include logo or something, insert logo something.
Yes, sir.
It will include at a correct place, wherever you want. Defined by the Beamer.
Yes.
But normal writing, there is a way, I don't remember what was that. I read it weirdly. There is a way. So that the page can be repeated as such for all the writing. There's some, I think they call it background image or something. I think Ravi was right in this.
how to plot Excel file using MATLAB?
Excel file they can include in MATLAB, like load it in MATLAB and then go on with plotting, like data. For data, I have shown how to include the thing with MATLAB. In the same way, they can load the Latex also. So here I have shown it. Load the iris data like over here. Load irism dot m. Similarly, they can load the corresponding file and then access their individual columns also, and they can use them for plotting.
Okay, if we have two JPEG figures, how can we insert one figure in another in LaTeX?
Two JPEG figure and want to insert one figure inside other.
Yes.
So there are specific softwares for it. And desired figure can be created and that can be imported into the LaTeX. No need to do that one in LaTeX as it is.
So figure embedding in LaTeX directly may be possible, but I haven't done it, of course.
Yeah, so two figures merging for that one, the merging of figures, there are Adobe software is already there, Adobe Photoshop and all those things are much better
Jyoti
than creating
Tripathi
it
would
in
like
LaTeX.
to ask something. I am unmuting Jyoti Tripathi. Jyoti Tripathi, you can ask your queries.
Yeah. Good afternoon, sir. Thank you for the presentation. Sir, I just want to know that as you have loaded the file using this .m extension, this iris data file you have loaded using .m extension.
Yes.
So first we need to change the extension, then only we can use any other data set file that is present.
Yeah, loading, there are many other options also to load.
So every
Not
time.
only .m, but
Yeah.
you can load many other figures also you can load.
So if I have a file with the .xml extension, then I can directly use that file?
Yes, you can load them also.
Okay. Thank you, sir. Thank you.
Right.
Do we need to specify any package before using equations? I think that is done. Especially with the commands that you explained today, yeah, that's done. Yeah, for inserting image in LaTeX, do we need to create any other image file like bibliography?
No need.
There's one question. Can you provide the PPT of today? There was no PPT which was used. It was only demonstration files, and these will be shared on Canvas.
Yes.
Any other query?
One query there, has it been answered? For inserting image in LaTeX, we need to create any another image like file, like bibliography. Oh, you've answered already.
After so many days, how to get LaTeX software? You can use it online using Overleaf, or first install Mixtec and then install Text Studio.
Until they can install on the desktop, they can use Overleaf.
Yeah, they can use Overleaf or they can use the desktop version. Here I have whatever I have demonstrated, that is on this desktop version. Mixtec and Text Studio.
Yeah, very good. Thanks. Nandaji, can you share your this source file which you have built in the LaTeX? I think one of them.
Sir, I have shared with you.
Only thing is you can
Email.
remove your images actually. आपके फोटो है ना उसमें वो आप चाहे तो हटा सकते
हाँ मेरे फोटो
ताकि
मैंने डेमोन्स्ट्रेट
सर
किया
रार
था।
फाइल, सर नंदा ने रार फाइल भेजा है सर?
मुझे नहीं मिला।
नहीं आपको भेजा है सर, दोनों
अच्छा।
पूरा जीप करके भेजा है सर।
अच्छा कोई बात नहीं, ठीक है रवि कर दो।
हाँ सर।
Only thing is Ravi, the
Sir.
images of Nanda should not be there. No? Somebody you should not good explain.
ओके सर।
You made a very huge file. Very good.
There's a question, can we create PPT in Latex? That is possible. Use Beamer package. Sorry, not the package, but the document class. Document class Beamer. It's available on Overleaf. That you can use the template and create.
I think today last lecture might be on that. Dr. MP Singh.
There's another question. How to insert dataset in MATLAB like Iris?
That I have demonstrated now, the data set. This is loading the data set like Iris. They can load the file directly.
So I don't see any more questions.
Yeah, this was the longest and marathon demonstration of this program. Still date. And a huge exposure. Very good.
Thank you, sir.
So we can close the session now.
Yes. Thank you, Dr. Satsainan. I think you have taken a lot of efforts. This was needed actually for the equations and the figures. Thank you very much. Thank you very much.
Thank you, Dr. Nanda.
Thank you, sir.
So for the afternoon session, we will rejoin again at 4. Thank you.